What did we cover last time? What are derivatives? What do they tell us? And what is that? What can we imply from this? If a function has a derivative, what can we imply? Very good. Excellent. You studied. That's fabulous. Yes, that's exactly what it means. If a derivative exists, it means the function is continuous. If the function is continuous, that means it's differentiable. That means at any point along the way, you can find the rate of change, the slope. Very good. Now we're going to look at all the different rules. For if you think about it, the library of functions that we went through, each one of those has its own derivative. Because any graph that exists has to have a derivative. So we're gonna look at here are the powers, the multiples, the sums, and differences. The first one we're going to look at. The derivative of a constant function. What is a constant function? What does the graph look like? Straight. Be more specific. All lines are straight. Excellent. Yes. A constant function is a horizontal line that crosses the y-axis at point C. So if we take the derivative of our function with respect to x, the derivative of our function with respect to x is equal to c. So we're looking at the derivative of the constant function with respect to x. What's the slope of a horizontal line? Very good. The derivative of a constant function of a number is always 0. Because, well, if you think about it, I'm jumping ahead here, but where can we use this concept from? Where can we use this idea in graphing? You thinking? Think of a graph. Let's think of a cubic function. At what points is the slope 0 on this function? Where are they located? And what's another name for them at those points? Not the x-intercepts. This thing goes on forever and ever and ever. Ever hear the word extrema? You should have been in college algebra and pre-cal. Okay, we'll cover that then. Extrema. What do you think an extrema is? That's plural. What's that? Or the high points or the low points, yes. So it's the highest or lowest points. You feel bad? Okay, yeah, no. Use sign language. Yeah, so it's the highest and or lowest point. So we call those extrema or relative maxima, relative minima. So it's on a curve. Whenever you see a curve, it's the highest or lowest points of those bends. Are they the highest of the entire picture or the lowest of the entire picture? No. If they were, then they would be called the absolute maxima and the absolute min. So what's the difference between relative and absolute? What does absolute mean? Everything. It's over the entire function. Is it the highest point of all the points? Is it the lowest point? Do you have to have those? No. Like, for example, this example does not have an absolute maxima or minima because graph goes on forever both ways. There is no high or low point, absolutely. But the relative maxima minima are on certain domains. You can have multiple relative maxima and minima. Can an absolute maximum be a relative maximum? If I had a graph that looked like this, how many maximas do I have here? How many high points do I have? Is this a high point? How do you know it's a high point? What defines it as? How do you know if you're on a roller coaster? How do you know you're at the highest point of the roller coaster? What happened to you just what were you doing just before you got to the highest point? Before you go down, what do you have to do? You have to go up. So if the slope is positive on one side and negative on the other side, so this slope is positive, this slope is negative. So that means at this point, what should the slope be? 0. Because you go from positive to negative, it eventually has to go to 0 first. So you have one maximum there. Here's another maximum right here because it's higher than everybody else. So how many relative maxima do I have here? 2. I have one there and one there. Relative maxima can be an absolute value, can be relative because it's over a small interval. How many absolute maxima can I have? 1. If it's the absolute, there's no other one bigger. So you can only have at most one absolute maxima. How many minimas do we have here? 2. We have a minimum there and we have a minimum there. What's this one called? It's the absolute minimum, but it's also could be called what? A relative minimum, because it's also the relative minima of that subdomain. So absolutes can be relatives. And that other one is a relative. So what's the condition for to be a minimum? What happens to the graph to the left of the minimum? Yeah, on the left of the minimum, it has to be negative. On the right, it has to be positive. It has to go down, then up. So that means this one here and this one here, the slopes are zero at the maximum minima, at the extrema. Another name for those are vertices. A vertex is a high or low point. How do we find them? We take the first derivative, set it equal to zero, and find out what x values make it zero. Those are the vertices. To understand calculus, mathematics, you have to be able to connect all this information that we're talking about. Everything we discussed since day one is related to the other topics. Everything. How do we prove that a function has a derivative? Well, in order to have a derivative, it has to have a limit. In order for the limit to exist, you have to be able to prove it with the epsilon delta. All this stuff we've talked about, everything relates. You have to be able to connect them all. Right? So let's look at another one. The derivative of a positive integer power. So we're looking at here, what if we had x to some, n could be any number you want it to be. N is some positive integer. Eventually we'll take it where n doesn't have to be an integer. It could be anything. It could be pi, it could be e, it could be anything. It could even be another equation. But right now we're looking at a power of a positive integer. How would we find the derivative with what we know so far? The difference quotient, yes. So we would have to find f of x plus h and have x plus h to some power and then do the difference quotient. Is that fun? No, because what if I had x to the power 5? You'd have to do x plus h times x plus h times x plus h times x plus 5 times. That would simply be the first part. So there's a shortcut for this. I told you there comes a shortcut. The derivative with respect to x of any power x, as long as the x is the base to some power. This is called the power rule. Whatever the power is, bring it down. And since you brought it down, you have to subtract the exponent by 1. That sounds pretty cool. So if I gave you f of x was x to the 7th, what is my first derivative? According to this rule, take the power, bring it out in front, and subtract 1. So this one goes out in front, so it's 7x, 7 minus 1 is 6. That's it. A lot faster than that difference quotient. Yes. Again, this is just to get used to the power rule. Last week, we took the derivative of, or we did the difference quotient of square root of x. Can we use the power rule here? How? Very good. There's a rule, a property that we can convert radicals into exponents. This number is called the root. And whenever you convert it to exponents, it's always on the bottom. So with this equation, we can convert it to 1/2. So what would our first derivative be with this information using the power rule we just had? So what do you have to do first? Remember, is the base an x? Yeah. This number here is the base. This is the exponent. As long as the base is x, we can follow the power rule. So what do we do first? Yeah, take the power, bring it out in front. Then what do you do with the exponent? Subtract 1. So whatever the exponent is, bring it out in front and subtract 1 from the power. So we have 1/2 x. What is 1/2 minus 1? Negative 1/2. Because what you could do, you have to get a common denominator. So this is 2 over 2. 1 minus 2 over 2 is negative 1 over 2. You could do the rules of algebra if you don't see it already. Remember, I told you from day one, calculus is nothing more than turbo algebra. You have to know your rules of algebra. If you don't know your rules of algebra, now is a perfect time to start reviewing them all. If you don't know it, this stuff's going to be a pain to you. So how do I rewrite this equation? How do I write that? Because remember, the rules of mathematics, you can never have a negative exponent. So how would I rewrite that? Because the rule is this. If you have a negative exponent, it goes on the other side of the dividing line and drops a negative. It doesn't make the answer negative, it just changes the location of the number. So this becomes 1 over 2x to the power 1/2. And then we have to go back. Since we started off in radicals, our answer has to end in radicals. So our final answer is that. That's the power rule. I'm going to give you 6 numbers, or 6 equations, functions, and you're going to give me the derivatives. There. Put it on pause, let you all have some minutes to work on it. Pretty straightforward. So the first one, what do we do there? Yeah, bring the power down and subtract 1. And there's your answer. Same thing with the second one. Bring the power down and subtract 1, which is 3 over 3, which makes it negative 1 over 3. So we have 2 over 3x to the power 1/3, which is 2, 3 to the cube root of x. The third one, bring down the power. And then what do you do with the exponent? Subtract 1. And there you have it. You don't need a calculator. Just leave it as square root of 2 minus 1. The fourth one, the first derivative. The first thing we have to do is rewrite this so it's an exponential rule. In a little bit, we're going to discuss how to do this the way it's situated. But right now, all we know is the power rule. So we have to put it as an exponent. The power comes down, which makes it negative 4. Subtract 1 makes it negative 5. So the answer is negative 4 over x to the 5th. And that's the answer for that one. What do you think so far? Easy, hard, complicated? Or is it just straightforward? This one, it's already set up. Bring the power down, negative 4/3, and subtract 1, which is 3 over 3, which makes it negative 7 over 3. So it's negative 4 over 3 x to the 7/3. Seven over 3 is the same thing as 2 1/3. So since that means it's x squared and x to the power 1/3. Using the rules of exponents. Which means my final answer, the cube root of x. You have to know all the rules of algebra. If you don't, then calculus will be almost impossible. Because you notice there's no calculator you can use anywhere here so far. So calculators are pretty much useless in calculus so far. Yes.
So how about if I wanted to flip that x over negative over 3,
If you want to do this one,
like to make the rational.
Oh, you could do that.
Okay.
Actually, to be honest with you, because of the complexity of this, here's the drawback, the limitations of using computers to do the grading. It will accept this because it's easier to grade this than it is this. But the rest of the world accepts this as the answer because you cannot leave an answer as a negative exponent. And even this is not right because you cannot leave a radical on the bottom. So yeah, because of the limitations of technology, the answers you may have are not truly the complete answers. It's going to take this. You're nowhere near the answer. So beware of that. Let's look at the last. The last one we could do it a couple of ways. What was the last one? So there's f of x equals the square root of x 2 plus pi. So what's my first thing I got to do? The first thing, I have to get rid of that radical. How do I get rid of the radical? Nope. Then we have this squared. You can't do that. Write it as an exponent. Because this is equal, I can go both directions. So now this radical becomes 1/2. Now, what do I do with these two powers? What's the rule for power to a power? How? Multiply. The rule, the rules for exponents in a nutshell are these. There are 5 or 6 more, but these are the basic ones. So since we have a power to a power, we multiply them. So that gives us x to the power 2 plus pi over 2. Now what do? What am I looking for? I could, if I wanted to, here, I could, since I have a monomial on the bottom, I could break it up into this. Since you have a single term, a monomial on the bottom, you could divide both of the numerator ones individually, which would give us this. That's not really going to make anything more difficult or easy, but which one do you think is going to make it's more fun to work with? Let's look at this one. The reason I would do this one, how do I find the derivative of this? How do I find, what's the steps of finding the derivative? So I really thought these shortcuts would be easier for you. What does the power rule tell us to do? Take the exponent, do what with it? Bring it out in front. And then what do you do with it up on top? Subtract 1. So the 1's cancel. There's our derivative. Because this one is divided by 2, we could go one step further and say that it's a square root of x to the pi. I cannot stress enough how important it is to know your rules of algebra. The more of those you know, the faster you can regurgitate them, the easier calculus is going to be for you. The derivative constant multiple rule. What do you think that means? What is a constant multiple? What is a constant multiple? What does a constant look like? A number. It's just a number. A constant is a number that never changes. It can't be x because x is a variable. It could be pi. It could be 3. It could be 7. Constant and multiple rule. What it's saying is I now have a constant that's in front of my x. So what would the derivative of this one be? Because what this is, you only take a derivative with respect to x. This is a constant. You don't have to worry about it. Don't do anything with it. So there's my constant. The derivative of this one is n x n minus 1. So it's n c x n minus 1. There is your constant multiple derivative. What's the derivative of this one? And for those of you who don't see that, this is my constant, so it goes in front. Now I take the derivative of x squared, which is 2 minus 1. So it's 3 times 2 is 6. 2 minus 1 is 1. And there I have it, 6x. Algebra. This is all algebra. Calculus, as I said, it's only the first, pretty much it's only the writing it down. That's all calculus is so far. What would the derivative of this one be? Very good. Negative 5x to the power 4. Because what's your constant multiple? Negative 1. Leave it there. I skipped this one. We started off by dealing with the derivative of a constant. What is the derivative of a constant? Zero. Here, we're looking at a linear equation. It's an x with no power. So using with what we know so far, what's the derivative going to be? The derivative is the slope. Remember, this is a linear equation. Y equals mx plus b. What number is in front of the x? The slope. So whatever number is in front of the x, that's your slope. So in other words, what this tells us, the x, if it's by itself, it disappears. Why? Why does the x turn into a 1? With what we did today, with using the power rule, how is that true? Exactly. So exponent is 1. Bring the 1 down, and power is 1 minus 1. What is x to the 0 power? 1. Again, you have to be able to connect everything we've done since day 1. You have to be able to connect it all. The derivative sum rule. Let's say h of x is equal to f plus g. It's a combination of two functions. What this thing says, if I take the derivative of h of x, what that really means is I take the derivative of each of these separately. Because the sum and difference rules, you treat them both independently. Look at an example here. Find the first derivative of this function. So the derivative. What's the derivative of the first one? Just 3x? 3x squared. Plus, what's the derivative of the next one? 8 over 3x. The derivative, it's minus the derivative of the next one. The derivative of the next one, 0. So there's a derivative. Okay, does everybody see why it's 8 over 3? Because when you bring the 2 down, it's 2 times 4 is 8 over 3. Imagine doing this, the difference quotient. So again, this saves so much time. Any questions so far? All right. So the next example, I'm going to have you do something else with it. Answer this question. Does the function f of x equals x to the fourth minus 2x squared plus 2 have any horizontal tangent lines? If so, where? What this means? What does this mean? Horizontal tangent lines. How is that important? How do we know if it's a horizontal tangent line? The slope is 0. So in other words, what it's looking for is our curve. Are there any points along the curve where the horizontal line only touches it at one point? That's what the tangent line is all about. So how do we figure this out? Remember, the slope is your first derivative. We have to find the first derivative and set it equal to 0. Again, put everything together. Our function is x to the fourth minus 2x squared plus 2. So the derivative is what? Four x cubed minus 4x. Set that equal to 0. And factor. So they both have a 4x in common. I factor out a 4x, that's what I have left. Okay, a lot of people have trouble with this part. They both have a 4 in common, so take that out. They both have 1x. How do I get the numbers inside here? Whenever you factor something out, to determine what goes in the parentheses, divide those. Since I took it out, I want to see what's left. So the 4's cancel. 1x cancels. So I have x squared. The 4's cancel, the x cancels, leaves me 1. Right here, what we would do is we would set both of these equations equal to 0 and solve for x. But remember from algebra, when it came factoring binomials, this is a difference of 2 squares, which means it's x plus 1, x minus 1. So this is another important information that you just talk about looking at it. What's the degree of our polynomial? 4. So what does the degree tell us? Number, or the maximum number of x-intercepts, or a number of solutions. That's what it tells us. So in our equation, we can have at most 4 x-intercepts. Since the degree is 4, and this is n, we call it n. So n minus 1 tells us the number of vertices. Vertices are where the slope is 0. So we have 4 minus 1 equals 3. We have to have 3 vertices in our equation. And sure enough, this is going to be 1, this is going to be 1, that's going to be 1. The horizontal tangent lines occur at x equals 0, -1, and +1. That's why I know I'm going to have vertices. Any questions so far? Anybody completely lost? All right. Let's look at, so far, we've always had x as a base or as just the function variable itself. Derivatives of exponential functions. When we say exponential function, the most common that we talk about is that. It can also be a to the power x, as long as a is positive, a does not equal 0, and a does not equal 1. So that's what this one means. I can have 2 to the power x. I can have 7 to the power x. The reason you don't want to have a being negative is because if a is negative, the base is negative, then it fluctuates between positive and negative depending on what the variable is, x is. If x is even, it's positive. X is odd, it's going to be negative if a is negative. What does E represent? You guys have heard that before. So what does E represent? It's called Euler's number. It's a specific value. 2.7181715. It's a constant number. It's used to define logarithmic equations, natural logarithmic equations. But if I gave you this as a question, what would the derivative be? it looks straightforward. In other words, is that always going to be the case? No. What's really happening, whenever you have a base that's not x, all you have to do now is take the derivative of the exponent. So if I had e to the 5x, the derivative would be the derivative of this function. What's the derivative of 5x? 5. And then leave this alone. So the derivative of exponential functions is whatever you have, it'll stay in the equation. What goes in front is the derivative of the exponent, which is why e to the x is e to the x. What's the derivative of x? 1. So it's the same thing. Like, oh, yeah. Because this defines logarithms. Exactly, yes. You see the conversion factor. Very good. What would, if f of x equals e to the power x cubed, what would what would my first derivative be? No, x cubed. Yeah, because you always, in your exponential derivative, you always have to have what you started off with. And this is just the derivative of the exponent. So far, so good? Because the same rule applies. Remember, we did the sum rules? The same rule applies for the difference rules. The derivative of difference function. So in other words, if h of x is f of x minus g of x, then the derivative of the entire function is the derivative of these two, and then combine like terms. Products and quotients. What does product mean? Multiplication. So this is f times g. And quotient means division. F divided by g. I could show you the entire long drawn out process. So for example, for the derivative of products, so if I have the derivative of f times g, what that one's going to equal is f dg dx plus g df dx. Don't worry about it. Don't memorize this. This is just a rule. I'm going to show you a shortcut for this. What this thing says is if you have a product of two functions, leave the first function alone, take the derivative of the second one, then leave the second one alone, take the derivative of the first. Again, it's more complicated than it sounds. Let me find the example here. Here we have y is equal to 1 over x squared plus e to the power x. That's a. And b, y equals e to the 2x. We know this one already. We've done this one already. What's the answer to that one going to be? Very good. Yeah, because this has to stay in the answer. Just take the derivative of the exponent, and that goes there. Now, what this one looks like is that it's a quotient rule. And instead of memorizing all those rules, I'm going to show you one rule that's going to work for both the product and the quotient. So this is h of x, or h of x. H of x is the product of these two functions. It's called the fishy rule because I invented it. I didn't think of another name. You'll see why I call it a fishy rule. On the top, put f and g. On the bottom, take the derivatives of f and g. Start from the g value and make a fish. Because it's multiplication, we add to make them bigger. Because when you multiply two things, they get bigger. So it's plus. So what this rule tells us is this. Take g times f prime plus f times g prime. And then once you have all these, just plug them in there, and there you have your answer. No, let's make one up. There. Find the derivative of this function. Remember, the first one is f, the second one is g. So we have f and g, f prime, g prime. F is 2x plus 1, and G is 3x squared minus 5x. The derivative of 2x plus 1 is 2. The derivative of G is 6x minus 5. So the derivative is G F. So start from here, go to the F prime plus F G prime. F G prime. And just plug those values in. So we have 3x squared minus 5x. F prime is 2. 2x plus 1 times 6x minus 5. Get rid of the parentheses. So 2 times 3 is 6x squared. Negative, positive is negative. 2 times 5 is 10x. 2 times 6 is 12x squared. 2 times negative 5 is negative 10x. Positive 6x. Negative 5. Combine these two like terms. So negative 10 plus 6 is negative 4x. So it's 12x squared minus 4x minus 5. This is, I mean, you all should be able to do this by now. This is just basic algebra here. Combine like terms. 6 plus 12 is 18. Negative 10, negative 4 is negative 14x. So there is my derivative. Now, it's the same rule for quotient rules, except one small difference. The example question we had was 1 over x squared plus e to the x. And that becomes x squared plus e to the x over x. The top is f and the bottom is g. To find the first derivative, we use the same fishy. So f is x squared plus e to the x. G is x. The derivative of f would be 2x plus e to the x. And g is 1. So far, everything's the same. Here are the only two differences. Since you're dividing, you're making things smaller, you subtract. So this one's going to be gf prime minus fg prime. And here's a second. whatever your denominator is, square it. Whatever your denominator is, square it. So look at this. We have x times 2x plus e to the x minus x squared plus e to the x times 1 over g squared, x squared. Get rid of the parentheses. 2x times x is 2x squared. X times e to the x is x e to the x. Since that's a 1, nothing changes. So I just distribute the negative sign. So it's minus x squared minus e to the x all over x squared. And that's all we can do. Because we can't combine x squares up here, because that's a 2. Well, we can. 2x squared minus 1x squared makes it 1x squared plus x e to the x minus e to the x all over x squared. Going much further won't change anything. And there's your derivative. Let's try bigger equations now. Y is equal to x squared minus 1, x cubed plus 1. That's A. B is we know what this next one's going to be is going to be. What's that going to be? Because the derivative of negative x is negative 1, which is just negative, and leave the e to the x. So we only have to do this problem. This is f, and that's g. So the f function is x squared minus 1. G is x cubed plus 1. Find the derivatives. So it's 2x, 3x squared. So the derivative is, since it's a fraction, we subtract. It's going to be g f prime minus f g prime over g squared. minus 2x squared over x cubed plus 1 squared. We'll combine these, we get 2x to the fourth plus 2x. Negative 3x squared times x squared is negative 3x to the fourth. Negative 3x squared times negative 1, negative makes it a positive 3x squared. And combine like terms. Negative 3x2 minus 3 is negative 1x to the fourth plus 3x squared plus 2x. And there's our derivative. What do you think? From 1 to 10, 10 being easy, 1 being hard. What do you think? 15? All right, let's combine these. It's possible to ruin your day with one of these. Y is equal to x minus 1, x squared minus 2x, all over x to the fourth. How would you go about doing this one? You can treat this as a quotient, but the top you have to do a product rule. Or there's another way. Since the denominator is a monomial, let's go ahead and FOIL the top. Get rid of the parentheses. So x times x squared is x cubed. Positive, negative is negative. X times 2x is 2x squared. Minus x squared is minus x squared. Negative is a positive 2x over x to the fourth. Combine like terms. Negative 2, negative 1x squared is negative 3x squared plus 2x. What would you do next? All of the top values have factor out an x on top. Anything cancel? Yeah. This x cancels with one of these. So there's only 3 left on the bottom. X squared minus 3x plus 2 over x cubed. Again, since it's a monomial, I can split up all of these and take them individually. I could change it from a quotient rule to a sum and difference rule. Two x's cancel, so I have 1 over x. 1x cancels, so I have 3 over x squared. How does this make it easier? This makes it easier because now I can change each of these to negative exponents and just do the power rule and the sum rule. What's the first one going to give me? Take a derivative of the first one. Do what with the exponent? Bring it out in front. And then subtract 1. So we have -2. Take the power, bring it down in front. And subtract 1, we have -3. Bring the power down. And subtract 1, we have -4. So that's my derivative. So I get -1 over x squared. Negative makes it a positive 6 over x cubed. Positive negative makes it a negative 6 over x to the 4th. And there's my answer. There is no wrong way of doing this. You could have used the quotient rule and the product rule if you wanted to, or any combination thereof. They're interchangeable as long as you follow the rules. So far, we've only been taking the first derivatives. You can take derivatives as long as the functions allow it. For example, for the trig functions, you could do the derivatives infinite times. You'll never end doing them. So they switch between sine and cosine. Find the first derivative. What's the first derivative going to be for this one? 3x squared minus 6x plus 0. It's a constant. All right. Now we can go the second derivative. The next derivative starts off from the first derivative. Let's take a derivative of the first derivative. What's the derivative of 3x squared? 6x. The derivative of 6x? 6. Let's do the third derivative. Yeah, and this one goes to 0. And the fourth derivative, once once we reach 4 and higher derivatives, we put them in numbers because the Roman numerals get too complex for a lot of people. So the derivative of the derivative of the third derivative is what? 0. So you can keep on taking derivatives as long as the functions allow it. Can we take a fifth derivative? The derivative of 0 is always going to be 0. All right. That does it for that section. Which is the reason why we learned higher order derivatives and how to take quotients and rationals, product rules. You have to know those rules to move on further. Practice those. Because now we're going to do the next section. We're going to start the next section.